Today we are going to build a buffer system. Okay, yeah, you heard it right. Buffer system is really important thing when you have millions of requests and you wanna perform millions of operation. I mean, you wanna do some operation on millions of requests. Maybe you wanna save that request on your database. Maybe that's millions request of orders created order, and you wanna save that into your database. Then the buffer system, building a buffer system is a good idea. Okay, it's really good idea, and also this is a industry practices. And in today's video, I will tell you how you can build a buffer system with Redis. Okay. By the way, this video is not a beginner friendly, but if you are a beginner, so no problem. If you if you want more knowledge, yeah, you can watch it. But if you are not a beginner, maybe you are an intermediate level developer, yeah, it's good for you. And if you know about this, how you can build this, then no point to watch this video. But if you don't know, and if you don't know how you can manage QQ system with a buffer, then it's this is the video for you. And if you are a beginner, so maybe this is the some extra information or some extra knowledge for you. Okay, for in this video I am not gonna talk about too much on the. Okay, so I prepared a whole diagram explanation. So let's go to our diagram explanation, and I will explain everything what we are building and how we will approach. And also after that we will see how you can implement that approach in the code. Okay, so now let's start. Let's first discuss what problem we are aiming to solve. Okay, let's suppose you have a system. Okay, so you have this client. Okay, so you have a client. Okay, client requested for something. Let's say client requested create my database. Okay, not create database. Let's suppose client requested to create something. Okay, a client requested to on your server to create something. Okay, let's suppose this is your server. I am not gonna going in the in depth, too much depth, but I am just telling you how you can work and how you can think about the system. And now let's suppose this is our server, and now your server, let's suppose this is your client thing. And the client, you have the millions of requests. Suppose you have millions of user, and this is something to maybe create order. Okay, so it's suppose a create order. Okay, it's suppose it's part of any e-commerce application, and you have order, and you receive millions of order per second, like Amazon, because Amazon receives millions of orders per second. So now suppose you have a system to receive I mean you have that much of traffic. Then someone let's requested to create order, and you have to create order, and now you received 1 million request. Okay, and now how your server will handle that request? Your server write that request, that request one by one, how you can handle these things. Okay, I'm not going to bit depth, but these kind of things is better handled by microservice. But I will not gonna discuss about the matter microservice completely. But it's not only server, it's order server. Okay, so let's suppose it's order server. Okay, it's order server. This is the small part of a microservice. Okay, so it's the order server. So how this will work? Let's see. If this receive an order from the front end, maybe you can build a wrapper server here, that make yeah, like this, a wrapper server which proxy to this server. Maybe you have a API gateway, other thing, but I prefer to build a wrapper server, that the client receive this wrapper. I mean client request the on this wrapper, and the client will get response from here, and this will pass that message into Kafka broker, and Kafka will send not broker, this will send a message to the Kafka topic, and this will receive message from the Kafka topic. This thing because I prefer to build this kind of thing, because I like to create a one server that's connect every microservices. And I always prefer to add TRPC here to make my request simple on my server, and also all the requests are handled by the one server. I don't want to remember the multiple servers where they are listed and how they are listed. I mean their domains, their endpoint. Okay, so I just want to know the one thing. But if you are using TRPC, maybe this will not gonna bother you. But if you are not using TRPC, maybe this will bother you. But I always prefer to write this way. I mean create my microservices server this way. This
This thing I find more valuable and more easy to do. But in our case, let's delete this. I'm not gonna talk about that. Okay, so now we have received, let's suppose we received order, like maybe we received order 1 million. So how we can handle this 1 million request on server? So how we will handle this 1 million order request? Then what we can do, we will create a queue. Okay, let's suppose you have the queuing system. Okay, so this is your queuing system. Let's suppose it's a queue, QUE and UE. Okay, let's suppose there is a queuing system. Maybe the queuing system of BullMQ. I Because I know, I have knowledge of the BullMQ. BullMQ is a really awesome library. Okay, for managing the queue system, retries, and maybe everything that you want. Okay, this is the Redis base. This store all the data on Redis. So now what you will do, you will publish. Okay, you will publish all the messages, you can say, the all the messages which you have received from the client for order. You will publish that here. Okay, you will publish that here. Okay, and now let's suppose make a publish into the queue. Okay, now you publish that message in the queue, and now you have a worker. Okay, let's suppose, by the way, this worker is on the same server, it's not on a different server. But if you want a different server, yeah, you can build, because this bullmq stores everything in your redis server. Okay, so you are able to connect from one server to another server. If you want to publish on other server and you want to receive on the other server, yeah, you can receive. Okay, just you have to define the worker on other server with same qq name. Okay, so currently we are handling everything in on same server. So there are no dedicated server. So in the queue, we have to define a queue first, and then we need to publish the message in the queue, and then we have to write a worker. Okay, so let's suppose there is a worker. It's a worker, and what this will do, it's a worker, and now the job of this worker to consume messages. Okay, this worker will consume the messages, and this will consume the messages, and also this will consume the messages. Okay, so this consumes the message and perform the operation which you have given. Okay, you first have to define what operation you want to perform or the messages. So one thing you already always have to do, you want to write the order information into the database. Okay, so what you have to do, you have to write, there is nothing to create a database, I mean, and now it's our database. And now you have in the worker, you have a logic to write all the orders in the database. But there is a problem. If you will receive 1 million requests per second, or more than that, or maybe below than that, who cares? But the only point of here, to just you have a messages. Okay, so when you will try to write the database, I mean write the message into database, then how you will make is more optimized. Okay, because your database have limit. Okay, your database have limit. Maybe you are using the postgres also have a low throughput. Okay, throughput means how many requests that can handle, maybe per second, I haven't remembered correctly, but it's something like this. And remember that thing, postgres database have low throughput. Okay, and redis database have too much high throughput. If you want any database which have a high throughput and it's an in-memory database, so you can use DuckDB. Okay, let me show you the DuckDB. I recently found this DuckDB. Okay, uh, it's an in-memory SQL database, and throughput of this around, I mean, almost 7,000 rows per second. It's too much and awesome thing, that much fast, and also it's fast and open source. They have also, oh, I think first I was when coming here, I seen a pricing section, but there is, I don't know why there is no pricing section. But by the way, this is free, so you can integrate this. These are the in-memory database, in-memory SQL database. So anything you will save, that will saved into your RAM. But if you wanna write the thing in the your RAM memory, I mean SSD, then you need to create a .db file. Okay, these things are handled by the DuckDB. Just you have to define where you want to save and on which file you want to write. Okay, so the thing that you can do here, okay, so if you ever you want to try this thing, you can try. By the way, not sponsored. I know who will sponsor this. These are the tech community things, so I am just sharing you. Okay, so now you will write the database. Let's suppose you are writing database over, too much than throughput of this database. Let's suppose the Postgres database. I don't know the throughput of this database for Postgres, but let's suppose you are writing data into this database higher than its throughput. Then there is too much high chance this data will gonna crash. Okay, it's highly chance this will gonna crash. Okay, so crash. So how you can handle this? By the way, you can handle this into your worker. Okay, because bull mq also provide limiters and worker concurrency. So by defining the concurrency and worker, you will able to limit how much data will write into this database per second. Okay, you have option. By the way, it's not per second. You have option to define how much time you want. Maybe you want 5000 messages per 2 second, 5000 messages per 3 second, 5000 messages per 1 second. So you have every control here in BullMQ. Let me again show you the website of BullMQ. Worry not, I am also planning a tutorial on crash course, you can say, on BullMQ, and I will teach you about the BullMQ, how you can process. And also I am planning to make tutorials of Kafka, we know kaiju number 8. Okay, so now okay, so now here, so by the way, where we are on, we was on the concurrency and the limiter. So BullMQ also has the concurrency and limiter. Concurrency means how many workers run parallelly to process that messages. These workers run parallelly to process message. Okay, if one message received by this, then rest of worker not gonna not will do not will not get that message. Okay, once a message consumed by a worker, other workers will not get that message. Okay, other workers will get different messages. So by using the concurrency, you can define you can make your system fast, because you are able to process the messages properly. Okay, so here the thing, but sometimes it's also not happening, because if let's suppose you have set the limiter, you have set 5000 messages per second, you are below the concurrent throughput of the your own database, me Postgres, MongoDB. Now let's there is one more problem. You are writing only one single messages at once. Let's suppose how much you are using the bandwidth. You are writing the one message, again come a one message, you are again write you again write let's suppose it's too much thing, too much thing to do. Then how you can solve this problem? So in today's video we will build this part to solve this problem. So here we need a buffer system. Okay, let's call it a buffer system. So it's a buffer system that's do simple job. It's our buffer system. It's a Redis based buffer. Why I am choosing the Redis? Because in the Redis, your data will persist. If your server crashes, then you will lose your buffer database, buffer messages. But if you are using the Redis, then you will probably not gonna lose your database. And it's in memory database, so sometime maybe you will be insecure for that. But there are also some settings you can enable. Then you can save or write a copy of your Redis database into your memory. Memory means SSD. But that things are beyond our discussion, so I'm not gonna discuss about that. Now we will pass the messages into our database. Buffer system. So our what will do our buffer system? Our buffer system collect all the messages. Okay, so it's a job of our buffer system. It collects all the messages. Okay, it collects all the messages. And now you have all the messages, and now what this will do, this will write all the database, all the messages into the database in at once, using transaction. Okay, Postgres transaction, using the Postgres transaction, this will write your all messages at once in your database. Now you can see you have optimized database writing server. Whatever you want to call this, you can call it. It's totally on you, but I prefer to call it a buffer system because I heard the name from the Pius Kirk channel. That time I was just started the programming, so Pius Kirk was explained about the buffer system. Basically he was explaining how notification system work. If you want to see, so you can go on YouTube and search Pius Karuk scalable notification system. In that scalable notification system, Pius Karuk explain about this. Okay, not about this how you can build this, but the things how working. But when I was saw that video, I was just started. You can say I was just getting started and the development field. So that time I was not able to understand, but now I am able to understand, and also I am able to teach you how things are working. So basically this will buffer all the data, all the message, and write using the transaction into the database. So this thing, okay, so this part, this buffer system we are going to build here. Okay, so we are building this. It's really it's a small thing, but it's really a good thing in industry, and every industry which have who have large messages to write, maybe more thing to perform operation, they are using this kind of buffer system, and this called in, I mean this counts into the best practices. Basically in this buffer system we define two rules. One is time based and one is batch based. Okay, so let's me write the rule. So these are the two rules which we can use. How this will work? Let's suppose we defined 5 seconds. Let's suppose that we defined 5 sec. Okay, so it's a 5 sec. Okay, so okay, it's we defined a 5 second. Okay, so here a 5 second, and after the 5 second, we do not care about the number of messages are buffered in our buffer system. We do not care about this. If 5 second completes, then write the message into our database. Okay, do this. And also our we have second rule. The second rule will defines the batch. Now suppose we have defined 500 messages. If our buffer have 500 messages, then write these 500 messages using transaction at once in our database. Okay, so we have two rules. We have the 5 second time based rule, and we have batch rules. Okay, whichever is built, I mean which which anyone bins, then perform by that. Okay, if any rules bins first, that will perform the database. Let's suppose your buffer have only 300 data buffered. Okay, then due to our logic, this will not gonna write into your database. But if you have also time based logic, then you in buffer you haven't a 500 messages, but you haven't a 500 messages, but your 5 second is completed. So here time based rule is bins. If time based rules bin, that write the data in our database. But suppose it's only 3 second, but now our buffer contain 500 messages. So now this time our batch based rule bins, and that will write data into our database. So this thing we are building, let's suppose it's looks like complex, but believe me it's really simple thing. Okay, believe me it's simple. It's too much simple. One thing I wanna write here, maybe someone raise question of this. We are using Redis here, so we will store all the buffer into the Redis. Okay, so it's Redis. Okay, I think I have already written here the Redis. Okay, so it's Redis. We are storing all the buffer in the Redis. And also here one more thing. If we write a database into our database, let's suppose you have written all the database, then one thing you also need to do, you need to clean these database from your buffer system. Also you need to write that logic. Okay, and one thing always remember. If suppose you are writing the database, let's suppose you are writing the database, first we will okay, let's suppose you are writing database and you are success in writing the database. Then what you will do, you will just now you have success. Okay, so you double C, you have success in writing database. So what you have to do, it's your first priority to clean all the messages. Let's suppose you are cleaning all the messages from the your buffer, maybe from your Redis queue you are removing all the messages. But let's suppose this is not the case. Let's suppose this is not the case. Your messages your messages are, writing your messages will failed. Okay, what it failed. Okay, it failed. Let's suppose it's failed. Now what? Now what we will do? If you if your system is like this, if your if your if your operation is failed to write your database, and also if you delete also if you delete the messages from your buffer, then you have you lost your database. Okay, so you lost your crucial order information. So how you can handle this? Okay, let's suppose this is handled by the transaction. Let's suppose here's a transaction. Let's suppose this is the transaction for our Postgres database. Let's suppose this whole is transaction. We are writing the transaction here. Don't go on my spelling, maybe this is not right, but let's suppose you have written the data. Okay, there is a transaction, so let's suppose you have multiple things to do. Maybe also you are checking something in database. In transaction you can do multiple thing at once, and there is also one operation you have to do, in the transaction. Why? I will explain, just wait for now. Here is a flush. I am calling the clearing the buffer called flush. Okay, it's flush. The flush, what the flush will do, if all the thing is done, may all not means all the thing, it's writing the flush. Okay, maybe it's flush. It's flush. What this will do, this will flush. Their job is to clear everything in the buffer from the batch. In the batch, if this batch contain 500 messages, so this the flush job is to clear that 500 messages. If this buffer contain 300 messages, then flush job is to create that written 300 messages. If suppose is this fails, if suppose this data db operation fails, then our code will stop here and throw error. Our code will not come here and do not flush the database. Okay, do not flush the database. Let's suppose, and one more thing, let's suppose one more scenario. If this success, this db success, and also this db write success, but our flush fail. Okay, our redis maybe go down, maybe something happen with our redis. We are not able to flush. We our system is crashed during the flushing. Then what? Your data is written into your database and also available into your buffer. That will create a duplicacy. Okay, okay, but in our case this will not create a duplicacy, because we are into the transaction, we are flushing the data into transaction. If in transaction any error occurred, okay, so that will revert back everything to the previous. If anything is written in database from here, maybe updated, anything is worked here, then that will revert back as initial. Okay, so no changes will gonna reflect in database, and also our flush will be safe, and there is no duplicacy created. Okay, so okay, now you understand how crucial this part for a system. Okay, this is really a crucial part of our system, and also we are going to build this in just a one class. Okay, we will create just one class, and one class have some method to handle this. Okay, and have rest of the thing automatic. Batch based thing will go automatic, and time based rule go automatic. Maybe you can say we are automating these things in code. That's really awesome thing. Okay, so now I think I have done in the explanation. If you like the explanation, then just comment me, tell me about my explanation, and also tell me you want these kind of awesome videos. Okay, believe me, it's really awesome thing to build. Here I have prepared a whole template for you. By the way, this is also available on my GitHub, so you can also come here, dev5 redis buffer, and you can access all the code. And after the video, after the publishing, I will update this README file. So worry not, and also you will get everything in the description. Okay, the link for this description. So you can also come here from the description. Okay, now let's see what we are doing. This is our index page, just showcasing the example how you can use. Our main code is in this file. Okay, You can say here. By the way, if you are thinking why I am not coding line by line, why I prepared everything here, so the reason behind this is I don't want to waste your time. Okay, and that's really a reason. Because it's not too hard to code line by line, but don't want to waste time, because I saw the multiple big YouTubers who is in the same field. They prepared a whole template to just explain us. The reason behind it simple. I don't know what in their mind, but in my mind, I don't want to waste your time, because coding line by line takes time. What's matter only here, what's the matters only logic, and how you can implement that logic in the code, and how your code will work. Okay, so that's the matter here. There is not a matter for create writing a code line by line. The matter of the logic, how things working, how you will think, how you will create, and man, that's whole about the thinking. That's why I am not writing the code. Okay, I am just explaining the code which I have already prepared for you guys. Okay, so there is, you can say, imports from the Redis. So we are using Redis for managing the Redis. Okay, it's a error formatter. Let's see what's inside this. Okay, this is the basic error formatter. Just checks the instance of, if instance of my error is error, then return this. If it is string, then return direct. If object contain messages, then return the messages. If not, then unknown error. If you want, you can perform any other operation. Maybe you have Axios error, maybe you have drizzle error, maybe you have Kafka JS error. Anything you have, you can define. Okay, it's my it's my way to do it. Here is a flush handler function, which is a generic function that takes t as a generic, and that will pass here. If you pass anything here, you will get item as a flush here. And also here is a flush function, you can say flux function returns okay. By the way, okay returned by the Redis side. That's why here is a promise with a string called okay. This flux is the same thing. Okay, maybe it's on Chrome. Yeah, here the same thing here, which we are talked about earlier. Okay, so the same thing. Now again, come on the VS Code, and now let's see what we are doing here. We are just creating. I mean, I am just creating a class. It's a Redis buffer class, and it's also generic. It's take a type generic, because we don't know what we will get inside this code. Was like what kind of data you wanna buffer, so we don't know. That's why here is a T. And also I make this optional by providing the unknown, because maybe you haven't a type, you don't know about the type. That's why it's unknown. Why unknown, why not any? Because the reason is any is not safe. Okay, in industry grade, I mean, you can say in industries, maybe you can say in the seniors developers, there is no place for any. That's why, as much as possible, ignore any, use instead of that unknown. Okay, it's a basic thing in industry and industry grade code, so ignore as much as possible. Okay, here is a client. I am taking the name client, a Redis client. It's type Redis. This take our Redis instance. Okay, naming as a client. If you want, you can name it as a Redis, but I am just naming client. Okay, a key. Why? What this key? Wait a minute. Redis client, and there is a key. What this key do? It's a Redis key. Okay, it's a Redis key, and it's a Redis key, and here you will pass any key. If you pass, suppose you want a buffer order, so you will pass something like create colon order, maybe else you want, but like this you will pass a key, and that key is your source. I mean, that key, in that key, your buffer, all the buffer will gonna store. Because if you know Redis, you know what I am talking. It's a key value thing. Okay, max batch size, it's clear, or is clear. Match batch size, defining, it's for the defining the rule which we have already talked. You can see batch based and time based. So the same thing I am doing here. Here I am providing a option whenever you will use this code any somewhere else in your project. You wanna set batch size, maybe you wanna add custom batch size as your use case. So that's why I am also adding a batch size here, which is a number, and it's a plus interval. Okay, by the way, this is the time in millisecond, time in ms. Okay, it's a time in millisecond. And it's interval id, just ignore it, you can ignore it, you will find that thing here. So not a big thing here. And here is the flush handler. By the way, if you're thinking why it's ignore interval ID, so region is we are for clearing the timeout thing. Maybe somehow you maybe in some cases you wanna stop your buffer, then that's will I mean, then that's the thing for this. I mean, okay, so worry not, I will explain this. Here the flush handler. This is the function. I mean, this will take a function that we have already discussed, and and in this function we will perform our transaction operation. You can see we have a full flexibility in our code. You can see this whole transaction operation, this whole I'm talking about this logic we can write in the flush handler. Okay, in the flush handler. Okay, I will explain, worry not, this is just taking this t, and you can say here the t, and now if you pass something here, that will get that type. Okay, it's flushing, it's just a constant. If you want, you can refer the worry not, I will explain flush handler. It's a flush handler. And let's see is AI gives me any suggestion. Flush interval, uh, flush interval id, I think it's good. Okay, so now here what we are doing, we are just calling a constructor. If you know about the class, you know the constructor. I am just setting all the values with their respective maybe prototype. I haven't remembered, maybe this is a prototype in the prototype, because everything in JavaScript is object. So here we are, this is the just a wrapper, you can say. This is just a skin on JavaScript object. In the JavaScript there is no class, it's just a skin, you can say. Maybe you can say a cover of book. Okay, so here in the from the option we're going to see here option, option have types, this type. In the option we are taking the batch size and 500. It's 500. Why we are taking this early? Because if a user specified batch size, then take that batch size. If not, users mean I mean developer. If you create any instance of this class somewhere in your code, from there you can define. You are and if you are intermediate developer, you know what I am saying and what I am trying to say. Okay, in the batch size, here the 500, take this 500. If user pass flush interval, then okay, if not, then default it's 5 seconds. Okay, and here the flush handler, yeah, okay, you can say developer need to pass the flush handler function. Here what we are doing, we are just setting a thing, a set interval, flush if not empty, and just interval which we are passing here. It's an interval, maybe it's 5 second, 10 second, jo bhi ho, anything. It's a interval, it's a flush empty. Let's first see what this will do. This will started when we will initialize this class. Okay, so let's see what this doing. This is doing the flush empty. If not empty, then check the length, and if length greater than 0, then flush. Flush means this will call the thing, I will explain, worry not. Then what this will flush, and this part, this is the part of this time based rule. Okay, this time based rule. Okay, our time based rule works here, and this is the, I think, 1 2 3 4 5 6. This single line code is for time based rule, and it's initialized when we initialize our class here. Okay, with our provided time interval. Okay, so now this is initialized, and this will start working and working and working and working until you stop it. And now here add. Okay, so it's add method to add new item in your buffer. Okay, you need to call this add item, and you need to pass the item here, and in the buffer that will take your item, and that will push in a r push, means this will create a list in the Redis, and the Redis that will take your provided key and store your JSON stringified data. And what this will now do, okay, after pushing this, always check, I mean always check if length key, I mean I mean to say, always check if there is something, I mean if our Redis list have something which have greater than our batch size, then flush. Okay, so our this is our second rule. Okay, our batch size rule. Yeah, you can say that I have already explained the batch size rule. Whenever I we will add anything in our buffer, then simultaneously is also calls a query in data in Redis to get all the list from the buffer. You can set the Redis and check the length. If length is greater than or equal to our provided batch size, then it will flush. Okay, it will flush. And also we have discussed about this. Now let's talk about the flush. Okay, so there is a flush. Okay, so if flushing means if something is flushing already, because we maybe it take time, I don't know how much time it will take, but if it's flushing, then do not flush it again to prevent overload pushes. If something is happening, if one flush is happening, do not perform other flush. That's why when you start the flush, so flush I mean, then set the flush true. Okay, now here what we are doing, we are taking the batch a client, okay, clients of Redis, and we are arrange and we are just getting the values, okay, the values with our provided batch size. Okay, so this batch size -1 from 0, it's our batch size. Okay, if the is raw data is equal to 0, maybe there then it's that's simple, nothing in our buffer. If nothing in our buffer, then reader no need to do anything. Okay, so now this is the flush. Okay, so this function is flush function, and the option the the work of this function is to just call this an ltrim and deletes the data which we already written in database. Maybe you can say the already in the patch which we have sent to writing in database. So that contain that thing here. Okay, but the thing is we are not calling here, we are passing this function as a parameter in the function, and when we write transaction we will call this. Okay, when we write transaction then we will call, we are not calling this function here, because if you call that function here, that this will delete your buffer before saving into your database. And maybe if we will not able to handle that cases which we have discussed about the error and success when to prevent our buffer from losing the data. So that's why that's the reason we are creating a function here, but we are not calling this function. So now what we are doing, just we are just parsing the our get our all the data into the javascript object. And here what we are doing, we are just calling this flush handler which is provided by the user. No, I'm user to me, I mean to say, where we will create an instance of this class. Okay, so here we will get the item, all the fetch, I mean all the buffer data of that patch or that time period pass as a first parameter, and this flush function passed as a second parameter. Okay, so if someone if I mean if from the instance we will pass this, and also we will get two parameter there to perform the operation. And also there is a catch. In the case just we are using our error formatter, and we are just flushing. We are, if everything is done, maybe there is error there, maybe there is something happened, maybe success. In any case make it false, because now we have done with flushing. And there is a stop, and the and the thing is to do is just clear our time interval which we have created. Yeah, if you I think it's not need to explain. And now let's see in the Redis, we are using the Redis, I have already told. It's a Redis client, we are creating the Redis client with some things, and also the operation, I mean listeners, with some listener, because we want to see what happened on server. So this is the simple things. And here we are creating a database using, okay, we do not need this here. Okay, so remove this. And now here we are using the Drizzle for our database. So I have created a database, you can see this is the database, and passing the schema. Let's see what's inside the schema. So schema have two things, user and their order, and also their relation. Okay, the same thing, the that's the thing here. And I think I have explained. Now let's see the use case, how we will use this. I have written all the use case here. Now let's see, we have created a instance, example one. So there is a one instance of Redis buffer. We are passing the user, and there is a user. Now after passing this, when you will ever hover here, so you have user array. you know what we will get here. So it's a Redis client. You can say the Redis client. I have already told you the Redis client, and also I infer the type from the uh, from the Drupal schema. So that's basic thing. Okay, so here I'm passing the key for our list and max batch. This I think I pass this to just show you. If you don't wanna pass, that will use default thing. Maybe you can make it 4. Anything you can maybe make it, you can make 1000, but recommended is to just 3 4 500, just not too much and not too much low. Okay, so it's somewhere around 400 300 500 is good. And the time interval you can use 5 second, which ideal, and ideal 5 second. So you can use, now you can see we are passing the flush handler, which we have talked. And now here we are creating the database transaction. Okay, in the transaction we are inserting our new users value, its users value. And if this success, then our code will come here and try to flush. The flush is to just stream the list from our database. Maybe you can say this will delete our written part in our main SQL database. If in this point Redis fail, then this will revert back as previous. No data will gonna save in the data. By the way, this is not limited to only for database. If you want, you can perform anything in your mind you can use there, and you can customize yourself. You can clone that repo, and you can do anything you want. And now you can see we are just adding. Okay, whenever you will create an instant for a buffer, after passing this, because we are using the new tag here, you can say we are not using the static class, then you can store states. So these you can call it, are the states of your class. And if you define once at in your code, anywhere in your code, maybe in utils, you can define this. You have, then you just have to add, you just have to call this the instance name dot add, and add your whatever value you wanna add. So you can add this, and this will add, you can say the database. Here the worker job is, this worker job is just to add. This will just this will just do our instance, class instance dot add, class instance dot add, class instance dot add, whenever a message come, and push into this pool. And this pool is responsible for doing all these things. Okay, and now here I have also shown you to one another example. You can say the same thing, user. I think I have created, okay, it's order, it's typo, order. Okay, order. Yeah, I'm creating the order, and with the max, I think I have changed something. Okay, worry not. Now you can see I am passing the batch size. If you don't want to pass, you can ignore it, because it's optional. We have set default thing. No, okay. And here the same thing, flush operation. You can do anything what you want, and with same instance I am just adding our order with respected user ID. Oh, that's simple, that's whole thing. And there is not more than this and not more than that. It's simple, and it's simple to build, it's simple to use. I don't know how people will gonna take it, but it's my approach, it's my logic, and it's my thinking. You can say it's my philosophy. If you have your different idea, you can do. But but I want a favor, just you will update me in comment, or somewhere else in your issues tab of GitHub. Just update me what improvement I can do. ah, I'm open to do, I'm open to take your suggestion. So just suggest me. And in the env there is only two thing, the Redis. I forgot to add the database URL. Let me add the database URL. uh, okay, so database URL, and also let me add to env.example the database URL. Okay, so now that's pretty much everything. I haven't taken you too much time, and I also prepared I also tell everything. So now bye.